Hello and welcome to another tutorial in the Coollab Discovery series. Today we will see an overview of the different kinds of nodes in Coollab. You probably noticed that we have different colors in the nodes drop-down menu. That's not a coincidence. The purpose of this tutorial is to familiarize the user with the compatibility between the various nodes. Furthermore, it will allow the user to discover and play with new types of nodes. As in, this tutorial may be longer than the previous ones. In the first part, we'll see the node compatibility, and then we'll see each category. Without further ado, let's get started. It is good to know that Coollab adopted a color scheme for its nodes. As you can see in the node menu, each category of nodes has a respective color. For example, green is used for shape nodes. We can mention the fact that nodes are arranged in a certain way in this menu. In fact, there is a bottom-up order for compatibility, starting from curved nodes. If we take a curve, we can link it to an input pin of the above types, as in a shape, or a grayscale or image, and so on. The general idea is represented with this simple scheme. Keep this scheme in mind, and let's take an example. If we start with a shape node, we can link its output to an image or grayscale node. In our case, we took a disk and we linked it to a grayscale node, as in fractal noise. So let's activate it, and it works. We can also apply any 2D modifier as they accept any 2D node, for example this grid here. And as you can see, it works as well. But on the other hand, if we try to link a shape to a curve modifier node, we'll get an error in the console panel. Indeed, a curve modifier, as it's in the name, is appropriated for curves, and a shape cannot be implicitly converted to a curve. So we will take a closer look at the different categories in the next section. A curve can be used as an image or a shape, but it can also do more. Some things are specific to curves. All the nodes related to them are represented by a magenta color. They're really fun to play with. We will give you a demonstration of a disk moving along a curve. As you can see, we were able to use the lemniscate curve as a path and the disk is moving along it. We can clearly notice the infinity shape of the lemniscate curve. Thanks to the point on curve, we extracted a point from the curve and assigned it to the center of the disk. The position of this point is determined by the current time. In the end, we obtain this smooth and satisfying animation. It is good to know that a curve always has a length of 1, 0 being the start of the curve and 1 its end. In this other example, we made good use of this property to create a drawing animation using the curve modifier curve portion. Here, the length value varies between 0 and 1, and as a result we have the impression of drawing the Lessager curve. Personally, I find this animation really classy and lovely. All the nodes related to shapes are represented by a green color. As it said in the name, we will find different shapes in this category, such as disks, rectangles, or polygons. They are often used as a starting point for an artwork. Thus, they are really popular. This category is pretty intuitive. It is important to note that even though a shape can be used as a regular image, it is more powerful than that. Some effects only works on shapes and not on images. For example, the glow and the outline, and more generally all the shape modifiers, shape blends, and shape renderers. Let's take a shape and attach a shape renderer node to it to see the application. In our case, we took a disk, but you can change this disk to whichever shape you want. To do this, you can right-click on the node, and you will see different shapes. So yeah, it is a way to change an existing shape to another. Let's change the disk to a star, for example. Okay, so now we have a star. So now let's activate the shape renderer glow to see how it is going on this shape. And as you can see, the glow affects the whole shape. All the nodes related to images are represented by a blue color. In the same way, gray is used for grayscale nodes. These nodes are mostly used to add various effects to our artworks thanks to the modifiers and blend nodes. Here, we use the node image, which allows us to import an image of our choice. By default, it is the Coollab logo. We applied an image modifier on it called chromatic aberration. Let's activate it, and with these parameters, we obtain this interesting result. Basically, image and grayscale nodes work the same. The only difference lies in the color. If you link an image to a grayscale input, you will end up losing the color. We linked a stippling effect to the chromatic aberration. Let's activate it, and as you can see, we lose the color and we only have this shade of gray. All the nodes related to 2D modifiers are represented by a white color. These modifiers can be used on any 2D node, such as curves, shapes, images, or grayscale. We have seen some in previous tutorials like the mirror repeating circle or the kaleidoscope. They generate amazing effects and are therefore very useful to create unique artworks. Note that the output of a 2D modifier is the same as the node it is linked to. For example, if you linked it previously to a shape, then its output is considered as a shape too. As in, on this example, we have a disk and it's linked to an hexagonal grid, which is a 2D modifier. Since the disk is a shape, the output here will be considered as a shape too. Hence, if I want to link another node, I can add a shape modifier because the output is effectively a shape. Let's select the outline, for example. As you can see, it works. All the nodes related to 3D shapes are represented by a yellow color. Similarly to the shapes node, we'll find here different shapes, but this time in 3D, such as cube, sphere, torus, etc. When we are working with 3D shapes, we can change the type of the camera to inspect the shape. Here, the 2D camera is active, so I can only move the shape relatively on the X and Y axis. Now if I click here again, the 3D camera is now active, and thus I can move along the Z axis to inspect the shape in a better way. We can add several modifiers for various results. Here we twisted our cube, then repeated it 3 times along each axis to obtain these marshmallows. And now, if you remember the node's compatibility scheme, it is effectively possible to link a 3D shape to an image input. And so we decided to add a chromatic aberration and a color ramp, for example, and as you can see, it's a wonderful result. All the miscellaneous nodes are represented by an orange color. This category basically serves as a catch-all. We find different inputs for the most part, such as 2D vectors, integers, or numbers. This is also where we can find the time node that we used for animation. On this example, we have a star, and as you can see, it has different parameters, and some are controlled by input nodes. For example, size is controlled by a certain float, as well as the number of branches is controlled by an integer. And at last, the roundness is controlled through time. If I press play, you can see what it does. We hope that this overview of the different nodes categories helped you to understand them and how they were handled inside Coollab. Now that you discovered several types of nodes, feel free to use them in your projects to create even more diversity in them. And this is the end of the last tutorial for the Coollab Discovery series. I hope you enjoyed the series so far. If so, do not hesitate to leave a like, to post any comments under the video, and more importantly and as always, feel free to subscribe to the channel if you do not want to miss out the next tutorials. That being said, see you later in another Coollab tutorial series. Bye bye!